All right, now we're going to move into some other examples of solving equations, and we're going to concentrate in this section on solving equations with variables on both sides of the equal sign, and that does change the game up a little bit. We'll talk about some special exceptions down at the bottom of the page, but when you have variables on both sides of the equation, you can't solve this equation until those variables are together on one side of the equal sign or another. It doesn't really matter if you subtract 9x to move over here with this 7x, or you subtract 7x to move over here with the 9x. But as this box says up here, generally speaking, most people would prefer to deal with a positive number instead of a negative number. So I'm just looking at example number A, and I'm thinking I'm going to subtract 7x from both sides so that I end up with 20 equaling positive 2x, not negative. I apologize for this pen. It's being wonky. I don't even know why it's showing up like this. So I have to see if I can fix this next time. Anyway, divide by 2, and we end up with x equaling 10. Pretty straightforward. On part B, again, I want my n's to be positive if at all possible when I collect them. So if I add 6n to both sides, I end up with 10 and equaling 50. Divide by 10, and you end up with n equaling 5. I think you can hear my phone ringing in the background. Not going to answer it. All right, number C. Again, we've got fractions going on in all terms of this equation, so we're going to clear out these fractions before we end up getting the w's on one side of the equal sign or the other. So the lowest common denominator between 4, 1, and 5 is 20. We're going to multiply through by 20. When we do that, 4 goes into 20 5 times. 5 times 3 is 15. 15 w. 1 goes into 20 20 times. 20 times a negative 4 is a negative 80. And we clear out the third term by saying 5 goes into 24 times. 4 times 8 is 32. Now we're ready to get the w's together. We can subtract 15 from both sides, and we end up with negative 80 equaling positive 17. W, divide both sides by 17, and your answer is going to end up being, I'm writing it over here, W is equal to negative 80 over 17, because that can't be simplified any further. Again, no mixed numbers. All you want to do is take out the common factors in the numerator and denominator, and you leave your answer in improper fraction form. Let's look at number D. I see distribution. We need to distribute this 4 before we can do, whoa, overshot the mark, before we can do much else. We have 4r minus 36 plus the 2 that's hanging on the back end equaling 12r plus 14. Combine your like terms. We get negative 36 and 2. That'll combine. So 4r minus 34 equals 12r plus 14. And now I'm going to move the 4r, which is smaller, to leave me with negative 34 equaling 8r plus 14. Apparently I can't write small enough. Good luck to you guys. Minus 14, minus 14, and we end up with negative, what is that, 48, equaling 8r, or r is going to equal negative 6 when you divide both sides by 8. So those are some basic examples of variables, solving equations with variables on both sides of the equal sign. But there's two other things that can happen when you have variables on both sides of the equal sign that cannot happen when you have just a variable on one side or the other. So you can have a situation where any number plugged in for the x makes the equation true. That's called an identity. And there are infinite, meaning forever, forever, amount of solutions. An infinite number of solutions. The other thing that can happen is you have no solution to your equation, and we also use this symbol called the null set to indicate there are no solutions, nothing will possibly work to make the equation true. So look at these two examples. Walk through these two examples with me. I'll switch to red, see if this looks a little bit better. We're going to do our distribution. We're just trucking along here. 2g minus 4 equals 2g minus 6. All looking good. Collect those like terms, remembering that a minus 4 and a minus 4 is not 0. It is minus 8. 2g minus 6. And then we'll subtract 2g from both sides. And what happens here? You get negative 8 equals negative 6. Your g's are gone. We know that negative 8 does not equal negative 6. This is a not true statement. So you can say to yourself, I'm going to put a big cross through that equal sign because they are not equal and there is no solution to this equation. There is no way that these two sides of the equation are ever going to balance. That's an example of the no solution. Let me give you an example of the identity. Again, we're going to distribute. We end up with 4a plus 8 equals 14 minus 6 plus 4a. Be careful when you're distributing. Watch your signs. So we're going to combine our like terms. 14 minus 6 is 8 plus 4a. And over here we have 4a plus 8. Do you notice? You can notice at this point right here that you have the exact same thing on both sides of the equal sign. But let's say you don't notice it. Let's say you want to subtract 4a to get those a's together. Again, the a's cancel out, and you end up with 8 equals 8. That is a true statement. That will forever be true. That means that any number that you put in for a on both sides of the equal sign is going to make a true statement. So this is an identity. And we also sometimes say that all real numbers are the solution, meaning any number will solve this equation successfully. So that takes us through to B, and you'll have your practice problems to work, but that's the end of the video. Bye.